Jai Hind students, I am back with my lectures, right? So I hope you all are studying real well, isn't it? Students, always remember, study like there's no tomorrow, because if you keep on putting off your studies for tomorrow, then you will probably be too late, right? So being a good student is less about the ability to rot and more about the desire to learn. So students, you have to learn the rules of the game, and then you have to play better than anyone else. And the rule to study is understanding the concepts and avoid any sort of cramming or rote learning, and you will definitely succeed, right? So students, let's start with this session. As I promised that I will be coming up with some more numericals based on free body diagram, right? So these are the 4 set of questions. So let's start with the first one then. It's a very interesting question. This is a system given. Mass m1 is lying on this inclined plane while mass m2 is hanging, right? And it is given that the system is at rest. So it is at equilibrium. So the net force acting on body of mass m1 as well as the net force acting on the body of mass m2 is 0, right? You are supposed to find out the force exerted by the inclined plane on the body of mass m1. What is the force exerted by the inclined plane on mass m1? So what is it, students? What we are supposed to find? Yes, it is the normal reaction. Force exerted by the inclined plane on the body, that is known as normal reaction. So here, reaction is to be found. And the expression for the reaction should be in terms of m1 and m2. Nothing else is given in the question, right? So let us assume that the angle which this inclined plane makes to the horizontal be theta. This we are assuming. So let's concentrate on this and let's draw the vector diagram, right? Let's draw all the forces. Well, the force acting over here is m2g. Students, it's entirely your wish to draw the free body diagram, or you can represent the forces acting in the given diagram, right? So this will be the tension. This is the tension. So one of the force acting on m1 would be its weight, which will be acting in the vertically downward direction. The other one would be the reaction. It is the force which acts perpendicular to the surface on which the body is placed. Right, students? So m1g, it can be resolved into 2 components, right? So one of the component is opposite to the reaction, and we have proved it. This angle is equal to this angle. So students, this component would be m1g cos theta, isn't it? While this component, the perpendicular component against or opposite to the direction of the tension, would be m1g sin theta. I hope it's clear. Okay, now let's construct the equation for body of mass m1, right? So since the body is given to be at rest, therefore it must be under the influence of balanced forces. That is, the net force acting over here must be 0. And that is possible only when the reaction, which is the force exerted by the inclined plane on this body, which is to be determined, is equal to m1g cos theta, right? Also T must be balancing m1g sin theta, right? So these are the pair of forces which must be balancing or cancelling the effect of each other. Now let's construct the equation for body of mass m2. It is also at rest, no net forces acting on it, therefore T must be equal to m2g. Put this as equation number 3, right? So from 2 and 3, what we get is, from 2 and 3, we get m1g sin theta is equal to m2g. So gg get cancelled So sin theta is equal to m2 divided by m1. So from sin theta we have to obtain the value of cos theta. So that can be done by considering this triangle. It's a right angle triangle. Suppose this is theta. Sine, it's perpendicular by hypotenuse. It is perpendicular and it is hypotenuse. Isn't it, students? Sin theta, it's perpendicular by hypotenuse. So using Pythagoras theorem, the base would be given by m1 square minus m2 square. Clear, students? So hypotenuse square is equal to base square plus perpendicular square. So by using that, we can easily determine the base. Now, cos theta, it would be equal to base over hypotenuse. So that is square root of m1 square minus m2 square divided by m1. Therefore, from equation 1, the force exerted by the inclined plane on the body of mass m1, which is the normal reaction, is given by m1 g cos theta. Cos theta may be written as square root of m1 square minus m2 square divided by m1. So m1 get cancelled. So we are left with r is equal to g square root of m1 square minus m2 square. Right, students? Or it may also be written as m1g square root of 1 minus m2 square divided by m1 square. So students, this is the answer. This is the force exerted by the inclined plane on the body of mass m1. Right? So let's proceed with the next question then. Next question is, students, find the tension in the cord connecting A and B. The tension in this cord is to be found, which is between the bodies A and B. And students, remember, the pulley is considered to be massless and frictionless. And also, the string under consideration in all the cases are to be considered to be inextensible as well as massless. Okay, let's proceed with the second question. We are supposed to find out the tension. So suppose that tension is P. Right? This tension is to be determined between A and B. Now before that, students, we need to find out the acceleration of each of the bodies. Here the acceleration of each of the bodies would be same. This diagram may be redrawn in this particular manner. This is the frictionless and massless pulley under consideration. Right? These two bodies can be combined together so as to consider it to be a single body of mass 4 kg. And over here, the mass is 2 kg. In the question it's given, all the three bodies A, B, C are of equal masses, each of 2 kg. Right? So these two can be combined together so as to consider it to be a single body of mass 4 kg. Suppose the acceleration is along this direction. So both the bodies will have the same acceleration. Isn't it? And here we are aware of the formula which is to be used, right? We can do it directly. So acceleration of the system would be m2 minus m1, where m2 is greater than m1, isn't it? So 4 minus 2 divided by 4 plus 2 into g. G can be taken as 10. Suppose it is 10. Right, students? So it is equal to 2 divided by 6 into 10. That is 20 by 6, that is 10 by 3 meter per second square. This is the acceleration. Which formula I made use of is A is equal to m1 minus m2 divided by m1 plus m2 into g. And here obviously m1 must be greater than m2. So this formula can be directly made use of here. Right? Now students, we obtained the acceleration. Now consider this body. Now consider the free body diagram of body A. Consider body A. Right? Let's consider this body. So, let's represent all the forces acting on this particular body. This is of body A and its mass is 2 kg. So, one is its weight, which will be in the vertically downward direction towards the center of the earth. The second one is the tension. This is the tension. And the body is getting accelerated in the downward direction, right? It's getting accelerated in the downward direction. So, it is getting accelerated in the downward direction. So, let's consider the equation for these two. 2g must be greater than t because the body is getting accelerated downwards. So, net force is 2g minus t. This is the net force acting on this body of mass 2 kg, right? We are talking about body A. And net force is equal to mass into acceleration. Mass of this body A is 2 kg and acceleration is A. So, substitute the value of A over here and substitute the value of g as 10. We can determine the value of tension, right? So, let's solve it. G can be taken as 10. So, 20 minus t is equal to 2 into A is 10 by 3. So, what we get is t is equal to 20 minus 20 by 3. So, if we solve it, it will be 40 by 3 Newton, or it will be 13.33 Newton. So, this is the force, or rather this is the tension in the string between the bodies A and B. So, such questions can be done directly by using this particular formula, right? So, we are over with question number B as well, right? We have done both these questions. Let's concentrate now on question number C. Next question. I will read the question for you. Each block is 8 meters above the ground initially. We are supposed to find out the time required by one of the block to reach the floor. So basically, each of these blocks are above 8 meters initially, and then this block is released. So obviously it will come down and it will move horizontally like this. So we are supposed to find out the time taken by a block of mass 3 kg so as to reach the floor. So time is to be determined. So in order to find time, we need to determine the acceleration, right? So let us consider this to be the acceleration. Now since the strings, it is inextensible, massless, therefore both the bodies must be of same acceleration. Both the bodies will cover equal displacement in a given time. So both the bodies will have same acceleration. Now this is tension, isn't it? Now let's represent the force. What is the weight of this body? It will be 3 into g, right? What will be the weight of this body? It will be 7 into g. And reaction, it always acts perpendicular to the surface over which the body is placed. So these are the forces acting on it. Now let's construct the equation using this diagram, right? So for body of mass 3 kg, what will be the equation? 3g is dominating one, the body 3 kg is getting accelerated downward. So net force would be 3g minus t. This is the net force, net external force. And as per Newton's second law, net external force is equal to mass into acceleration. So its mass is 3 and acceleration is a. Why this negative sign? Because these two forces are oppositely directed. The angle between these two vectors is 180 degree. And students, whenever the vectors are inclined at an angle of 180 degree, then the magnitude of the resultant is given by the difference in the magnitude of the two vectors. Isn't it? So I am making use of basics of laws of vector addition. Now let's consider the equation for 7 kg. For body of mass 7 kg. Right? Now look, this body is having acceleration towards right. In the vertical direction, it's not having any motion. So R must balance 7g. These are the balance forces along the vertical direction. So the net force acting would be T. The net force acting on this body is T, and net force as per Newton's second law is mass into acceleration. So what is its mass? 7. What is the acceleration of this body? It's A. So this is the second equation, right? So using these two, we can easily get the value of A, isn't it? So from 1 and 2, we get 3g minus, substitute the value of T as 7 over here, is equal to 3A, or 3g is equal to 10A. So A would be equal to 3g by 10. If you consider the value of g as 10 meter per second square, we will get acceleration as 3 meter per second square, right? So this is it. We have obtained the acceleration, which is 3 meter per second square. Now initially the body is over here. Initially obviously it is at rest. So for body of mass 3 kg, both the bodies are initially at rest. So initial velocity is 0. Acceleration of the body is 3 meter per second square. The displacement which it needs to cover so as to reach the floor is 8 meter. Initially it is at a height of 8 meter above the ground initially, right? So in order to reach the floor or the ground, it has to traverse a distance of 8 meter. And we are supposed to find out the time. It's the case of uniformly accelerated motion. So we are supposed to make use of equations of motion. So the equation of motion connecting these would be the second one, displacement time relationship, which is S equals to ut plus half a t square. So let's substitute the value. S is 8, u is 0, so this term will get eliminated. Half acceleration is obtained to be 3 into t square. Right, students? So what we get is t square, it would be equal to 16 by 3, or taking only positive sign, t would be equal to 4 by root 3. So that would be equal to 4 root 3 by 3 seconds. So this will be the answer. This is the time taken by the body of mass 3 kg to reach the floor. Right? So this is all it needs to be done. Okay, I'm sure you have noted down this solution. You have understood it clearly. Now let's proceed to the last question. D. That is, we are supposed to find out the normal force of contact between the two given bodies of masses 6 kg and 4 kg respectively. So let's try to evaluate it. Students, remember, normal force of contact between the two bodies, right? Normal means perpendicular. Force of contact, which is the common force between the two bodies at the point of contact of those two bodies. So, as this system is pushed along this direction with a force of 10 Newton, the bodies will move along that direction and it will have some acceleration. So both the bodies will have acceleration of 8. And contact force between these two bodies, not between the body and the ground, between these two bodies. What is the contact force? This is the contact force. This is the contact force. Right? It will act normally, and this is the surface of contact of the two bodies. So this is to be found. Let us consider to be F dash. Whatever force is exerted by 6 kg body on 4 kg mass, the same force will be exerted by 4 kg mass on 6 kg mass, as per action-reaction concept, isn't it? So this F dash is to be calculated. F dash is the contact force between these two bodies under consideration of masses 6 kg and 4 kg respectively, right? So let's try to attempt the fourth question then. This is the situation. These are the two bodies given, one of 6 kg, the other one of 4 kg. And the system is applied a force of 10 Newton. Right, students? First and foremost, let's try to find out the acceleration of the system. Obviously, acceleration will be along this direction. Net force is equal to mass into acceleration. Net force acting on the system as a whole is 10. What is the mass of the system? It is 6 plus 4 acceleration. So A would be equal to 1 meter per second square. So students, this will be the acceleration of each of the two bodies, right? Now, as I told you, when a force of 10 Newton is applied on 6 kg body, the 6 kg body will also exert some force on the 4 kg body. It will exert some force on the 4 kg body. And the same, that is equal and opposite force, will be exerted by the 4 kg body on the 6 kg body. So this is the normal force of contact between the two bodies, which is to be determined. Right? So let's, in this case, try to draw the free body diagram. Okay, let's consider for body of mass 6 kg. Right? So let's try to draw the free body diagram of this 6 kg. What are the forces acting on it? Over here, it is 10 Newton. This F dash, it is acting in the opposite direction. This is F dash. Acceleration is obviously along this direction. Its weight, it is 6g. It will get exactly cancelled by the normal reaction. No doubt regarding this. Isn't it, students? These are the forces acting over here. R and 6g are balanced forces. No need to write this actually. So, in the absence of any frictional force between the two surfaces in contact, this statement can be avoided actually. So, R and 6g, they are balanced forces. They are nullifying the effect of each other. Now, the bodies are having acceleration towards right, horizontally. So, 10 must be greater than F dash. These two are opposite directed. So, what will be the equation? 10 minus F dash is equal to, this is net force acting on it, is equal to mass into acceleration. Mass is 6, acceleration is A. So, what do we get? 10 minus F dash is equal to 6, A is obtained to be 1. So, F dash would be equal to 10 minus 6, that is 4 Newton. So, students, the contact force, the normal force of contact between the two bodies is 4 Newton. Right? The same answer could be also obtained by drawing the free body diagram of body of mass 4 kg as well. Let's do that as well. So now, let us try to obtain the same answer using the free body diagram of the body of mass 4 kg. Right? We must obtain the same answer. Okay. For body of mass 4 kg. Okay, this is it. Okay, what are the forces acting on it? F dash along this direction. Acceleration is along this direction. Its weight is 4g. And reaction, suppose it is R dash. Obviously, this reaction R dash will balance 4g, right? The body is having acceleration in the horizontal direction. So, what is the net force acting on this body? It is F dash. And students, net force acting on a body is mass into acceleration. What is its mass? 4. And acceleration is A. So, F dash is equal to 4. Acceleration, we have determined its value, it is 1. So, F dash is equal to 4 Newton. Isn't it? So, students, it's entirely upon you to decide which body is to be considered. On either case, whether you consider 6 kg mass or 4 kg mass, the answer would be same, right? So I hope you have understood these questions, right? So just be thorough with the concepts. And students, as I very often keep telling you, do practice as many numericals as possible, and that will give you immense confidence, right? So that is the only way to gain in confidence, by doing more and more and more numericals. So that's it for this particular session, students. And do join me in my next lecture then. Thank you and have a blessed day.